Hi, I'm John McDermott. The following video is a recording of the IoT Auckland Meetup that took place on the 22nd of April, and it features an interview with Tindale of Spidertracks, who's outlining their system for aircraft monitoring and tracking. Plus, we have some other news of the Internet of Things that are taking place. I hope you enjoy.
Right, so hopefully you can see my screen now. So let's make a little start. So just give you a quick overview of the agenda. So I've got a couple of news items I picked out, which I thought might be interesting to cover. And if anyone wants to comment, then unmute yourself and shout out. Be interested to get some feedback on some of this. I ought to point out that if you hadn't realized, I am recording the session that we do today, and the intent is I'll edit through that over the weekend and then put it up on YouTube. After the last meetup we did a couple of weeks ago, I did the same, and I've edited that, and I've made an IoT Auckland Meetup YouTube channel now. So if you have a look on there, you'll find a couple of videos, and we'll add to that and see how we can develop that as we go along. I think as I get a bit more practice, then doing this kind of online format could be quite interesting, especially for getting these type of presentations out and having them online for future reference as well. So let me just go through a couple of the slides then. We've still got people joining us. So a couple of kind of COVID-related items I thought was, clearly topical and interesting to comment on. One which I thought was kind of amused me in a way was the Raspberry Pi Foundation shipping 640,000 units in March, which I think was was 100,000 higher than their normal monthly average. And I think there was a clear people interested in IoT and wanting to have something to do whilst they were locked in at home. So it's good to see people just experimenting and hacking away. But there was also this this stream of what can be done, and there's several projects by the looks of things using Raspberry Pis for building ventilators. So I thought that was really interesting to see that people are recognizing that off-the-shelf technology can be developed, and there's open source designs of ventilators being made. So it's interesting to see that level of response taking place. What did I have next? So the other one was around contact tracing, and this is something that I've been taking an interest in and making a couple of contributions to. And it's interesting to look at the diversity of comment that's going on around this, and where does technology fit into what's being done. It's very easy for technologists to suggest technology as a solution, but looking at the discussion around this, it's quite clear that there's actually some bigger issues to be taken account of in this. And every use of technology, has issues around, does it really fit the purpose, and are people able to effectively use it? And the other thing that became clear while looking at this is every country's context is different. So what is right for one particular country to do doesn't necessarily mean that that's going to be right for any other country or every country to do. The Trace Together app has come out of Singapore, and I think that's been kind of looked at as the best standard at the moment, both technically and the way it's being deployed. But there are issues with that as well. One of the interesting things about Trace Together is it's being made available as an open source application. So Blue Trace is the background software to that, and you can go onto that website and look at how they developed it and use their code as the basis for other apps. So I looked through the details of that. the other couple of comments that I've noticed about that is, and I'll come on to this on the next slide in a way, is does it actually work properly? And there's issues around Bluetooth and contact tracing actually working properly as you would expect it to. And the other one, which I think is actually quite critical, is everything to do with data privacy. And it's looking like the data privacy angle is what's going to cause the most issues about how technology is going to be used. So then moving on from that is the discussion in New Zealand, and there are contact tracing apps being created. And one of the key suggestions, which I've noticed in the last few days, week, is around making a Bluetooth card for contact tracing, which I think has got some really interesting perspectives around how it's get used and who uses it, you know, and it not being an app on your phone. So if I just move on to my next slide, we can discuss that a little bit more. So the piece of information which I think really underpins what are the problems is Apple and Google are building a contact tracing capability into their operating systems now. So there's an expectation that in the next few days, few weeks, there'll be an update to Android and iOS building in a native contact tracing capability using Bluetooth. So the first issue is, does everyone have a smartphone? Can their smartphone get that update? If they do get that update, do they use it, and how's it being used? And one particular friction over this that I noticed this morning is the French government are disagreeing with Google over how that app will work and what it can do. And the two problems which are coming up from that is, for a non-operating system application, so a software developer creates an application, puts it in the App Store, you need to get the user's permission to use Bluetooth. And because of the data privacy concerns around Bluetooth collecting information continuously, those applications won't run in the background. So now they have to be on all the time, and they're draining your battery life. If you turn your phone off, the application stops working. So there's some technology concerns about how those are going to work. And then it's like, who owns the data and how do you get access to it? And the French want to be able to track individuals. So they have individual identifying information, and Google and Apple are creating their applications in a way that there is no identifying information with the data that's being generated. So that permission angle gets rises up again. And I think that's going to be one of the fundamental concerns over, do contact tracing applications on your phone actually get accepted and then work appropriately in the use environment. So that then leads back onto these kind of non-smartphone applications. So we just looked at the suggestion around making a card, and another company I'm aware of, which is Estimote, who is one of the, I think, a global leader in Bluetooth IoT applications. They've created a device for workplace contact tracing. And what's interesting about this is, again, it's not the smartphone app, and they use ultra wideband radio technology inside that as well, which means they can get very precise distancing information very rapidly. So down to the centimeter level, which when you want to check, are your workers keeping 2 meters apart, is actually one of the key requirements. So this idea about using devices rather than smartphones, I think, is an interesting one to keep an eye on. So yeah, I'll pause and take a breath there for a moment. If anyone wants to make a comment on that, then unclick your mic and give a shout out. I'd be interested to hear some feedback. If not, I'll move on to my next topic. So Graham, I was going to slot you in here for a quick chat about the latest on Arduinos.
Anyway, so I have acquired some of these Cubecells that John put a picture of on the screen a moment ago.
I'll just go back to that.
So the Cubecell is a new module level device that does LoRa, and it is programmable through the Arduino IDE, and it has essentially the entire LoRaWAN stack built into it, or at least in the Arduino code that's provided with it. So it is a small device. You can't see how small this is, but it's actually substantially smaller than the ESP32 based devices that I've worked with before, at least. It's narrower, which means it fits better on a breadboard, and it's got plenty of pins. So it's got six I/O pins, which is nice. It also has built into it a solar power input and a battery charging and management unit. So it's really designed that it can be very much a deployed into the field device with very low sleep power. They say on the battery connected through its connector at the back, it goes down to 3.5 microamps of power being used, or of current. That's really very low compared to anything I've seen before. So it looks to me like a pretty attractive piece of equipment. I'd say for development purposes, you can buy it in breadboard friendly modules. If you're trying to deploy something, then that turquoisey thing that says Cubecell, and that is Cubecell as opposed to Lubelel written on it. That piece is available alone, and you can integrate it into your own stuff. If John could turn that thing over, which he probably can't, on the back it would say FCC and CE, and the significance of that is that the module is approved for use by the US Federal Communications Commission and the EU. At least that's the implication of the stenciling on the back. And again, that, compared to a lot of the stuff that we've seen out of China, that's useful because it means that you're not going to get shut away in a federal penitentiary for selling it or using it. Yeah, it's got an unusual microcontroller on, and there is some talk about that not necessarily being particularly compatible with some of the sensor libraries that are available out there. Interestingly, the makers, Heltec, sell it as a bundle with options of half a dozen different kinds of sensors and all the code necessary to run them. And so they've actually done a lot of work, and there is a lot of example code to go with this thing. Curiously, a lot of that example code has a copyright message from Alibaba. I don't know what the connection is between Alibaba and Heltec. Perhaps Alibaba owns Heltec, I'm not sure, but this is a very well integrated bit of kit with lots of code going on already. Compared to the ESP32s that I've seen before, it's a lot lower power. It seems to work. I mean, it boots up into LoRaWAN. It's got a strange interface that you can build for it, an AT command interface, where most of the standard things you would need to do to configure a LoRa end node, you can do from the keyboard through the serial terminal. So all those long strings that you would type in to connect up to an app, you can just type in effectively, or cut and paste in, which I think is very interesting. It means you don't actually have to write code to connect it up to something. You can do it very much interactively, save it, and walk away. There's an interesting question about the maturity of this thing. The device itself has apparently been sold since 2017. And as I say, there's oodles of manufacturer example code in the Arduino package that comes with it. But it's now 2020 and the hardware is still Rev 1. There doesn't seem to be a lot of third-party code around for it. And if you go to the vendor forums for support on it, there's quite a number of unanswered questions, things that are asked and never answered. So that to me tells me that it's a bit before its time, perhaps. It is using the new Semtech 1262 chip. And the interesting thing about that is that that chip covers the whole of the ISM band that LoRa uses. So right from 433 megahertz at the bottom end up to 923 megahertz at the top. It's a very broad range of stuff in one device. And when you order it, you specify what range you want. But I think the only thing that changes in that is the aerial they provide with it. Yeah, so that's the Cubecell wrapped up. I've been playing with it. It seems to work better and more quickly than the other things I've tried before. So I'm impressed.
And Graham, I'm not sure if you said, can you remind us how much did it cost?
Oh, I think it is about $12 US for this development board.
Okay, so that is cheap.
For breadboard component, yep. Yep.
No, interesting. So I had not seen this device before, so I was quite intrigued to see it because, you know, I've used other Arduino LoRaWAN boards and there are a few shields about, and this level of integration is actually quite rare, and more effort that's driving the price point down is really interesting to see as well.
Yeah, to me, the idea that it's got all the battery management and the solar power thing built in is quite remarkable at this price point.
Okay. So if there's any questions or comments, shout out or write them away. Otherwise, I think we can move on a little bit. It's kind of interesting doing this online format. The pace is a lot higher, so we get through things quickly. So I think Sean will be ready for you. So I'll just do a quick introduction. Spidertracks, I think, is one of the most interesting technology companies in Auckland at present. You may not realize, but it's actually been going for a number of years, and Sean may touch on that in a moment. What they provide is aircraft tracking solution, and I won't go into any details because that'll be taking the wind out of Sean's sails. But I think what's really nice to see for the whole team there is the High-Tech Awards this year, which just got announced a couple of weeks ago. Spidertracks is a finalist for Company of the Year. So not just a finalist for one of the awards, but the finalist for, you know, kind of the award. So very pleasing for the team. And Sean's let me know that there are some job roles available at Spidertracks right now. So I think we're going to touch on those, but I'll share some information about that when I email around to everyone in the next couple of days. So Sean, if you're ready, I'll hand over to you.
Yeah, thank you, John. Thank you for the intro. I hope I can live up to that. Let me quickly switch over presentation mode here. Okay, well, why don't I hit it? So my focus today is to talk to you about what I think is a really cool little technology company here in Auckland, as John mentioned, called Spidertracks. And I want to talk to you a little bit about what our past has been. We're a 13-year-old company with a good, strong history in aviation. So I want to talk to you a little bit about that, give you some context to what our journey has been so far. And then I want to talk about what we're up to right now and what the future holds for us. Let me switch over. We have this little internal joke within our organization that no presentation referring to Spidertracks can start without reference to this slide here, which is our vision. And really, we do live this vision through and throughout our company, be it in the sales marketing organization or in the technology function of our organization. We really do exist to make aviation a safer place to be. And our ultimate vision is to become the benchmark for safety across the world for the particular customer segment that we focus on and look after. So these aren't just words on a slide. These aren't just words on our wall in our office. We talk about it all the time. We're referring to it constantly when we're doing planning sessions, when we're having team retrospectives, etc. We live it through and through. It's very authentic to us. So I want to start by, talking, when I talk about the history of Spidertracks, I think a good place to start is obviously from the beginning. And it's perhaps a little bit negative, a little bit of a slightly more grey topic to talk about what was the impotence or what was the spark that started Spidertracks. But unfortunately, it was a rather tragic event that happened in New Zealand back in 2015, where this helicopter you see on the left here, which is a Eurocopter EC-120 for the aviation nerds out there. Back in 2015, there was actually an unfortunate incident where this helicopter was on a mission from, you can see on the right there, from a scheduled mission anyway. Their plan was to go from Auckland down to Queenstown. And they made a little bit of a detour on their way down, unbeknown to the folks monitoring their flight, into Raglan. And unfortunately, they suffered from an incident which is, unfortunately, one of the largest contributors to fatalities in helicopters anyway, which is what we call an inadvertent IMC, instrument meteorological conditions, which is when as an aircraft you're flying along through clear visual flight rules conditions. You can see where you're flying to, you can see the conditions in front of you. And then unfortunately this helicopter, when they flew into the region around Raglan, they flew into cloud cover. The pilot needed to make a very quick transition from visual flight rules to instrument flight rules, where they're now looking down into their cockpit, letting instruments guide them to what's happening around them. And that's actually quite a tricky thing to do as a pilot, especially when those conditions come into you very quickly. So unfortunately, in this case, it didn't go well. There was an incident. This helicopter was downed over Raglan. But the folks who were, the loved ones, the folks monitoring this flight, waiting for the flight to arrive in Queenstown, didn't know that the flight was obviously downed in Raglan. So, when the helicopter didn't show up at their scheduled time, they alerted search and rescue. And what I believe the protocol is for search and rescue to start at the destination for where the aircraft is intended to land, their destination, and then work their way up the flight path, or in our case here, work their way up the country. And so that, if you start in Queenstown, that's a very long way from Raglan. So obviously that took a very long time for them to eventually get up into Raglan and find the aircraft in some pretty rugged, forested location. And the thing that's quite tragic is that it took them, I believe, about 15 days there or so to find the aircraft. 15 days in New Zealand in 2015. That's pretty interesting. When I first heard the story, I thought that was quite poor, actually, that it took in the order of 2 weeks to find an aircraft that was down locally in New Zealand. We're not talking in the middle of the Pacific or the Tasman. So obviously that is a problem. That's not really acceptable. That's not good enough. So our founder, a chap named James McCarthy, who I believe was a university student at the time in Massey, thought actually there's got to be a better solution to this. In 2015 we can't have aircraft going down and not being able to find them for 2 weeks. So that was the spark that created this organization, was to try and solve that problem. So enter our products that aim to have really solved that problem. So what we do as an organization today is we do satellite orientated aircraft tracking. We have the thing we sell is a little bit of hardware that you see on the top right there that we call a Spider, and it is a satellite data connected device, and that is going via, for those familiar with satellite communications, the Iridium satellite network. That is using the Iridium satellite network to communicate back to a platform that we've built over time. and our customers can see in real time the location of their aircraft on a map, on a web-based or phone application based interface. They can see what's happening with their aircraft right now, and they can also apply some context to what their aircraft is doing right now via aviation specific maps, such as weather maps that are orientated towards aviation, and maps that are orientated towards visual flight rules, which is a very specific area of piloting aircraft. So that was the solution to the problem, and the business, started around that 2015 point, had a lot of great traction and great success. James, I won't attempt to tell the story of the early days of Spidertracks. I wasn't in the business then, but James, when he talks about that, it was very much a true grassroots New Zealand startup, a lot of hustle and a lot of burning the midnight oil to service the customers, at least in the early days. Then around, I think it was 2013, the business introduced a new product on top of the core tracking functionality, which we call Spider Text, which is what you referred there in the bottom kind of right. And that is, basic, let's say, ground staff to cockpit folks sitting in the cockpit, be it co-pilot, passenger, or pilot itself, text messaging. And the thing that's unique about that is that works via our applications. It's integrated into our solutions, and it also works via the satellite network. So regardless of where you are in the world, you might be in the outback of Australia in the middle of nowhere, or you might be in the wilderness in Canada. If you have a view of the sky, the likelihood is that you can communicate with folks that are interested in your flight or care about your safety. You can communicate them via text messaging. You don't have to rely on cell coverage within those very remote locations, and often cell coverage just simply doesn't exist in those remote locations. So that's what our products essentially do. We've been very focused for the last 13 years or so on doing a really great job in that domain. And I guess you can say that when you look at this, we were doing IoT, or the organization was doing IoT before we really called it IoT 13 years ago. And we now have this acronym that we can start to, in a generic sense, refer to what we do and start to categorize the technology that we're exposed to in our company. I want to talk a bit about our customers. So our customers the customers we focus on are in the general aviation space. So general aviation isn't Air New Zealand, it isn't Qantas. General aviation is the helicopter that you might see flying in the sky of Auckland every now and then that the police operate, or the Westpac search and rescue helicopter, or aircraft that are used to charter, light aircraft that are used to charter flights out to, Great Barrier Island, or to remote locations in Canada, like I mentioned before. We really are focused on that lighter, smaller aircraft segment. And the distribution of our customer base is 60-40, so 60% of our customers, around about 50% of our customers are rotor aircraft, helicopters, and 40% of light fixed-wing aircraft. Probably the reason why we have a few more rotor aircraft in our customer base is they tend to focus on slightly more risky, dangerous missions, be it search and rescue, that kind of thing. So they tend to be possibly a little bit more safety aware or driven to adopt the sort of solution that we provide. So yeah, that's a very important thing. So we're very, very focused on light aircraft. We don't operate below that in terms of the size of aircraft and drones or anything like that. We're very focused on what they call the general aviation sector. Little bit of trivia, a little bit of kind of key stats around our customer base. So within our platform over that 13 or so year history, we've tracked over 10 million. It'll be well over that number now. Actually, we need to refresh these stats, but we've certainly tracked over 10 million flight hours. We have those recorded in our platform. We look after 6,500 aircraft around the world. those 6,500 aircraft are distributed across about 103 countries, is my understanding. So we are a truly global scale organisation run here from New Zealand. And then we estimate that the value of that fleet of 6,500 aircraft that we monitor is in excess of $6 billion worth of assets. So there's, you know, a fair amount of impact, I guess you could say, that this little organisation in New Zealand's having, which we're very, very proud of. So I guess that gives a little bit of a kind of history lesson of sorts around, you know, where we've been, what our mission has been to date. And it's really, the way we summarize it is, it's been about helping our customers understand where the aircraft is right now, and is the aircraft actually okay. And the business has done really, really well with that over its 13-year history. But we're now starting to transition into our next, I guess, really ambitious phase with the business, where we're trying to really double down on product development again, and extend our strategy into helping our customers understand not only where their aircraft is now, but how has the aircraft been flown in the past, and then what can we predict from past behavior to give our customers insights into how their fleets are likely to be operated going forward. So, you know, there's a lot of problems that we can help our customers solve by stepping into this, I guess, new category of functionality or focus. One thing that is very problematic, I guess you could say, or a challenge in the industry, is that a lot of the aircraft that fit into the sector, the average age is about 25 years old, is my understanding. So they predominantly have analog instrumentation within them. So the ability for those folks operating those aircraft to leverage some of the awesome technology that we have nowadays is pretty limited. They've got these little analog islands that they can't tap into and record any historical information on. So what we want to help our customers do is essentially digitize the analog instrumentation, you know, what's happening in the aircraft from an analog sense, and bring that up into the cloud, where we have, you know, a lot of powerful technology at our fingertips, and then start to add value on top of that data and produce insights into how their fleets are operating. So we have a number of targeted problems to solve around how aircraft, for instance, are being maintained. The industry, due to a lack of data and accurate reporting, is, in the maintenance sense, is actually fairly inaccurately maintained, and folks tend to err on the side of caution and almost over maintain the aircraft. So we believe that we can help our customers more efficiently maintain the aircraft, and only get certain maintenance events rolled out into the aircraft when it's absolutely needed and indicated by objective data. And then we still will not lose sight of what is the core of our business, which is safety, like I mentioned at the top of the presentation. So I guess our ultimate goal is that everything reconciles to making aviation safer. So, you know, where we can help our customers modify behavior within their organizations to make operations safer, we'll do that through the data that we have. So if I take a really, really high level view of sort of what our roadmap looks like, we are doing a lot of work in the, I guess, the IoT hardware space within aircraft right now. We're producing a new IoT platform, which I'll talk about shortly. And we're wanting to use that as a way of pumping data, this analog data in a digital form, pumping that data out of an aircraft into the cloud, where we can do so much more with it. And some of the first things that we're looking to do with that is obviously, I think the most basic thing we could do is a simplistic analytics view of that. So what are the basic trends? What has this aircraft done this month? And an ability to drill into that data. I refer to that as very simplistic aviation operations analytics. Then once we've got a level of maturity around that capability, we're looking to leverage some rules-based analysis on that data, where we can tease out reporting on exceedances, for instance, like if an aircraft is being flown outside of its design envelope, we want to tell customers about that, obviously. So that's a lot of rules-based analysis and insight production that we, development of insights that we want to do. But then ultimately we're wanting to remove the need for us to take a rules-based approach to analysing that data, and we want to layer on some modern machine learning techniques to do things like anomaly detection, trend detection, that kind of thing. And then whatever we do with this tech, right, is you can get very complex with this. We can get carried away with the tech, but we have to bring it back to decisions for our customers. So whatever we do, and it's also something that's been in our DNA for a long time, is being super simplistic with the presentation of that. So we will be giving these insights to our customers in a very focused, distilled manner that will say, hey, this, essentially, hey, this is what happened with your aircraft. We believe you can do better by doing X. So it's almost more challenging to do that rather than just providing only that bulk sort of data analytics view that I talked about earlier. Anyway, that's a very brief skim across the surface of broadly what our roadmap looks like. So I mentioned, right now what we're focused on is a lot of development in the IoT hardware space, and what that means for us is a real modernization of the hardware that we have available to our customers that we sell. So I showed you earlier the SpiderX, which has been a great device for the company, very, very successful. But we're wanting to take that, the Spider 6, we're wanting to take that to the next level and introduce a new hardware platform that we call the SpiderX. And the SpiderX, I guess, is probably, from my perspective, my personal opinion anyway, the first really, really true IoT connected and capable device that the company will be delivering to market. It'll have, I guess, IoT gateway capabilities, where it will be able to pump data from a magnitude of devices that will be peripherals to it. And as you can see, there's a few of the highlights of the capabilities that it brings. So we're introducing, which is a bit of a step change for us, we're introducing cellular data connectivity. And really the cellular data connectivity gives us a bigger pipe to send data back to our platform and leverage some of the new sensor capabilities that are built into the Spider that I didn't mention before. So what you see there also has the ability to understand what's going on in the cockpit from a temperature perspective. How is the aircraft being flown in terms of yaw, pitch, roll? And then it has a barometer in it. So, what is the true altitude of how the aircraft's being flown right now? So it can do that all independently before we even start thinking about adding peripherals to it. So we're really excited about this. It's we've launched it in terms of messaging to the market, and we're looking to ship it this quarter by the end of June, start actually getting units out in our customers' hands. We have it in a few aircraft right now for some of our beta testing, and that's going really well. And yeah, I'm looking forward to giving the team a big party, hopefully, when we're out of lockdown and when we're shipping units very, very soon. Then just switching across quickly, so very hardware focused, but we are stepping into a platform now to back the hardware that we're delivering. We're building what you see here right now on the left hand side. We're building this actively right now, so we really, like I mentioned before, want to take that raw IoT data and add value on top of it for our customers. And we get the opportunity to modernize our platform in the process as well. So we are thinking about consuming our new device via standards-based IoT interfaces. So we're using MQTT, which many of you will know about. And we're using that as our generic interface into our platform to initially just service our hardware platform, but we aim to also in the future open that up to third parties who can talk MQTT in a particular category of data, we'll be able to work with them. Under the hood, driving all of these insights is essentially a data lake that we're building, as we speak, literally right now. And that data lake, for those who are familiar, is going to be able to not only take our data, but also third-party unstructured data and enable us in a much more, manual way, flexible way to process that and produce future insights, such as what I've talked about before. And then obviously we're working to enhance our applications. So this is a really big focus area for us right now, in parallel with our hardware. Spidertracks is quite an interesting company because we are predominantly a SaaS company. Most of our revenue comes from software as a service subscriptions, but we also have this hardware component to get access to our platform as well. So for me personally, that's been a really interesting thing, being a person that's mostly come from a true SaaS or software background. And then I think finally, I've talked a little bit about this new Spider, which you see there on the left, installed in an aircraft flying out. I believe that's around Ardmore, so sort of southeast Auckland this aircraft's flying in. So there's the new Spider installed. And for us, we don't just want to ship another widget to our customers. We want to give them a new capability straight off the bat when they receive that. And for us, that's going to be an ability for them to do a post-flight review of their flights with the SpiderX via a 3D flight replay. And if I quickly boot that up, see how my internet's going. I made the mistake of not warming up. There we go. Not warming up the demo before we started here. So what you see here is obviously a 3D animation of real flight data. So what we call AHARS data, which is basically your pitch roll that'll be coming off a device in the cockpit, feeding into our platform that's backing a 3D animation like this via our website. So this is a demonstration we've done for a number of our customers, and it's what we're working to productionize right now. Again, I think this flight is out southeast Auckland around Ardmore for those interested. So this has quite a lot of utility for analyzing an incident, for instance, that's happened on a flight, and seeing what the lead up to that incident might have been. And it also is a good training tool for students learning to fly, where they can sit down and get a 3D flight replay of what's been, how they flew the aircraft, and get some coaching around that. So we're pretty excited to be able to do this, and this is just the start for us, providing this type of capability. We're looking to also layer on some of those insights I talked about before, where an aircraft might be flown outside of its flight envelope. We're looking to layer on those, I guess, expediences is what we call them in our company. Layer those on as perhaps icons or insights across the flight path to let our customers know at this point, this is a point of interest. You might want to drill into this data, and they'll be able to drill into that from the visualization here. Cool. So that's our future, and that's what we're about. And I'm happy to take any questions we might have at this stage.
I'll chuck a couple in to start off with, Sean. Thanks very much. So kind of rolling back to the beginning of your presentation, one of the kind of lessons I think we can take away from this is around what value do your customers see in Spidertracks? And I think there was a really interesting mix of the kind of obvious, this is the data from your flight, but then you're leading into what else you do. So I'm just curious, from a pure sales point of view, what do people value from what you're doing when they come up to buy? What's that buying decision like?
Yeah, it's a really good question. So it's it's fundamentally about peace of mind for our customers. It's avoiding a situation where an aircraft might go down and you can't find that aircraft for up to 2 weeks, for instance. Like I started the presentation with, that's I don't think anyone would disagree with me that that's an unacceptable situation. So it's not only avoiding that situation, but it's allowing customers to have the peace of mind that everything's okay, or if something isn't okay, I can get to an incident very quickly and do something about it. There's this thing, I don't know too much about it, I'm not an expert on this, but this thing roughly called the golden hour, where there's some research around if you can get to an aviation incident within an hour, your chances of preserving life are so much greater. I forget the exact level, how much greater they are, but it's a lot greater chance of saving life, preserving life, if you can get there within an hour. So we want to give customers A, peace of mind, everything's okay, and B, if there's an incident, I guess another kind of peace of mind is that they'll be able to respond to it very, very quickly and not be looking for a downed aircraft in the wrong location. So our customers really value that. And then the thing in addition to that is the simplicity of our solution. So if I go back to our hardware here, so the Spider, this is the Spider, what we call the Spider 6 in the top right here. That's a very simple bit of kit to install in an aircraft. Possibly one of the most simple installations any technician will do in an aircraft. Essentially, it's a clip-on device that's typically mounted on a dashboard, and our customers really value that simplicity. They don't have to take the aircraft out of service for a long period of time to have a very sophisticated or involved installation process, or expensive installation process. It's very, very simplistic. So that's something that Spidertracks also has done really well over its history, is stay simple.
Oh, good. No, that's really interesting to see. It's an observation I make looking at lots of IoT businesses, whether local or lessons we can get from overseas, is, what's the real value people are wanting to buy, and then how do they justify that purchase? And especially in a business context, they're looking for, does it save me time? Does it save me cost? And I think there's some clear messages that come out of Spidertracks around that.
Yeah, absolutely. Some of the folks that we look after as well have some much stronger commercial drivers around insurance, for instance. Like some insurance coverage will require customers to have a monitoring solution in place as well. So there is apart from, I guess, the more human emotional driver around reassurance of safety, there's also some commercial angles as well.
I just saw a question pop up from Raphael there around suitability for commercial or long haul use. Now, I realize you said you focused on general aviation, but it might be interesting just to comment on that kind of technical difference between commercial operations versus general aviation.
So commercial, let's say scheduled aviation, which is the likes of an Air New Zealand or a Qantas, they've needed to have these types of solutions in place for a long, long time, which I'm really glad as a customer of Air New Zealand. So I'm really glad that they've had to have those solutions in place. And we're talking about also vastly different values and assets here. So the aircraft that we look after are typically, let's say, under $1 million in value, whereas 777, Boeing 777 that Air New Zealand operates is hundreds of millions of dollars. So you're really talking about a completely different tier of capital expenditure and technology layout in the aircraft, and that they are fully digitized aircraft from day one. Whereas I mentioned before, the aircraft we look after tend to be around about 25 years old in general, on average, and analog in nature.
Okay, cool, thanks. You mentioned something about you're increasing the team size and doing more development. Do you want to briefly touch on what type of roles and skills you're looking for, and how you're doing in recruiting that?
Yeah, I'm sure anybody on the call that does technology recruitment in the New Zealand market will agree with me that it's tough. There's definitely global shortage of tech talent, and we experience that. So we've found building out our team to be, we've definitely had some success, but we've found it really, really challenging. And in particular, if I'm really transparent with you, some of the more modern, let's switch to more modern, more, let's say, new school cloud data technologies that are underpinning what we're building here in terms of our aviation data platform. Some of those skill sets have been very, very difficult to find, and you need to be really open-minded about developing people, and not just trying to take a selfish view on it, and just wanting to grab somebody out of the market that has that skill from day one and can run with it. That's nice, but you need to also blend that with some flexibility around professional development for the folks that you have in your business or might be bringing into your business as well. So yeah, we are kind of taking a blended approach there of developing people in the business and recruiting new folks. So we have a real drive on right now to bring more data engineering capability into our business to help us continue to build out our data lake that's consuming this IoT data. And then later they'll be involved in some of these analysis and machine learning topics. But for now, we're wanting to add more and more new categories of data into our platform. So we're really keen to talk to anybody that has an AWS cloud background. We're very aligned to the AWS cloud, and in particular, if you've utilized some of their serverless newer school, it's my term, newer school data tech, we'd love to talk to you, because we're building a team around that skill set right now.
All right, thanks, John. I just saw a couple of other questions or comments come in, so I'll just go through these. So Rodney's just asked a brief question about what you've seen around the impact of COVID on general aviation, and whether that affects your business prospects over the longer term.
It's a really, really good question. So Spidertracks is within, I've been very high level and generic about the term general aviation today, I think. Within that, there's many, many different verticals of that market, and Spidertracks is fortunately very diversified within that general aviation market. So many of our customers operate in quite, let's say, essential categories of service out in the world, such as police, military, search and rescue, air medical, those sorts of things. So we've seen our customers in those, let's say, more essential service domains be in demand, continue to be in demand during this time. The sector of our customer base that has been impacted, which will be no surprise to anybody on the call, is those that are aligned with tourism. So customers who might be doing scenic flights around the Grand Canyon, as a random example. Unfortunately, their businesses overnight have seemed to have ground to a halt, given the current context. And we're really focused on trying to help them right now. So our sales folks are really doing a lot of footwork, virtual footwork, albeit, to see how we can give those types of customers some relief right now while their businesses are effectively paused. But those customers represent quite a small subset of our overall customer base. I forget off the top of my head what that customer base is. It's somewhere in the order of under 20%. So I've actually, as someone who's still relatively new to the company, I've been with the company for about a year, I've actually been quite surprised with how resilient an aviation company such as Spidertracks has been during this time. So we're still really confident and really optimistic, hence why we still recruiting folks. We're still building the team. We're still stepping into this strategy I've talked to you about today. We're still stepping forward into that. Nothing's changed from a strategic point for us, and we still see an optimistic view for the long term.
All right, good. See, Dave Blackwell's made a comment around if you can see your business, you can manage your business. So, very fundamental observation there, which is, good to point out. And having that, as well as the safety perspective, that coordination or operational efficiency makes a massive difference.
It's really interesting because you have some customers that will actually, much like we are as a business, stepping confidently into our strategy. Some businesses, even if they're grounded right now, will be stepping confidently forward, working on their businesses. So if their fleet, let's say you're a popular tourism company doing scenic flights around Grand Canyon, and your fleet is grounded right now, that's actually a really good opportunity to work on your business and improve the capability of your fleet, and maybe bring forward some of those technology projects that improve efficiency in your company. Bring them forward now where you have an opportunity to essentially not disrupt operations and work on your business. So we have seen some customers step forward with that sort of confidence as well. So it's a real mixed bag. It's a fascinating time for any business, and I'm sure everybody is learning a lot right now.
Okay, look, I'm going to have to move on. So I'm going to give a huge thanks to Sean for taking the time to kind of share this with us. It's really been interesting to hear about Spidertracks and see the success you have had and the value of what you're doing, and also the kind of confidence in the future, and make further investments and the bigger opportunity that lies out there. So congratulations, and thank you very much.
Cool. Thanks for the opportunity to talk, John. Thank you very much. Thanks, everyone. Nice to kind of meet you virtually.
Thanks. What I'll do is I'll just flick back to my screen for a moment, and only a couple more minutes, and then we'll be done. What I wanted to lastly mention is around a IoT communications network here in New Zealand. You heard Graham at the beginning touch on the LoRa WAN device. Now, LoRa WAN as a network technology is actually quite widely used in New Zealand for lots of different purposes, but it's a bit patchy, and different people are using it in different ways and putting out their own pieces of network. Now, I think LoRa WAN's got a bigger role to play, but this problem of how do we achieve a national network, I still think needs resolving. So now I've been giving this a bit of thought, and been looking at this for actually quite some months, from what I see happening here in New Zealand and people I talk to, and looking at different businesses and opportunities. So anyway, I've written up an article proposing to create a national LoRa WAN network for all of these applications. And the demand for this comes around saying, if you wanted to deploy an application, you don't have to worry about building your own network. There is a network that's already in place, and it's available end to end across the country. The problem with doing this is you really, really want a low-cost network, because as Graham's devices showed you, they're a few dollars. You only want to spend cents or fractions of a cent on the message cost. So achieving that at scale is actually really difficult. You need big applications, and it takes a lot of capital, and the capital is part of the problem. And I think there's a role here for having a demand and creating a national network. So I've put a proposal together. It's on LinkedIn. I'd be really keen if you can go across and have a read of that. I do have a white paper available as well, which goes into a lot more detail of what this network's used for, how it's justified, how it gets created and managed. And I'm really interested in feedback, primarily around the use case and the applications, but also to some extent the operational model of what technology and how it gets built out and operated. So I think that's that's kind of more or less the last comment I had to make. Take a pause for a moment. So if anyone else wants anything to comment on or say, they're welcome to hang around for a few minutes, so we can have more of a casual chat, and any other questions that crop up. Otherwise, I just want to wrap up by saying thank you for taking the time for coming along. Doing online has been an interesting experience, and we can do more of these. When we're able to, we'll be back at the Newmarket Innovation Precinct at the University of Auckland, and continue to make use of their very excellent facilities that they make available for us, which we're very grateful for. And of course, if anyone else sees any interesting news or knows someone that would be good to hear about, let me know, and more than welcome to carry on talking with people.